father is working from home. Suddenly the doorbell rings. He opens the door. Multiple boxes are arriving. Still minding his own business. In the evening, the father is sitting alone in the couch. Sorry. So in the evening, the father is sitting alone in the couch. The rest of the family, so the mother and 2 daughters, are going through the boxes. This has become the new normal in a lot of families nowadays. But just imagine the really transportation and logistical challenges this brings. So that is what we do. We are in the transportation and logistics to help customers make this happen. And by the way, that was actually me. So over to the agenda for today. So I will start with introducing myself and the company I work for. I will speak a bit about our current solution and our current architecture, and also the reason why we needed a new generation of a solution and the architecture behind that one. I'm Lieven. You can always contact me on that email address. I started in the company as a system engineer, got involved in managing MongoDB on premise, and now I'm a data architect in the company. I'm the internal go-to guy for MongoDB Atlas-related stuff, and also consulting teams with data modeling and database design. ZF, can I have a raise of hands who doesn't know ZF? ZF is a global technology company providing services and products for the passenger car, commercial vehicle, and industrial solutions market. This means there is almost no car running around in Europe or driving around in Europe that doesn't have a ZF part in it. Within that big group, you see the numbers. I'm part of a smaller group, the System Solutions Digital, and we are formerly known as Transix, so people in our business know the Transix name. We were taken over by WAPCO, and WAPCO took over, and ZF took over WAPCO. So we are really in the market of helping transportation, as I said in my story. We are building software and hardware solutions for the transportation and logistical industry. This is our current offering, Sky. It's a full suite of connected solutions. On the left, you see all the hardware solutions we have. These are devices for track and tracing to be installed in trucks, trailers. We have some devices with screens on it to interact with the drivers in a truck. We have devices for door locking solutions. So, for example, if a trailer can only be opened from the back end, from the dispatcher. On the right, you see our software solutions. These are really the basics. Stuff is, of course, a track and tracing application. We are building on top of that fuel management solutions. We have our hardware devices are able to connect to the CAN bus of a trailer or a truck, like, for example, the EBS system on a trailer, but also to the CAN bus of a truck. So we are getting a lot of sensor info from those vehicles. So we use them to present a vehicle health dashboard. Then also the eco-behavior of drivers. We have a big solution around eco-behavior, so fuel efficiency. We do train drivers being fuel efficient. And on the right side there, you have our social analytics, we call that. That's, of course, due to the European legislation of remaining driving and resting time. So we deliver a real-time view to dispatching, to fleet managers of the remaining driving and resting time a driver has. Now we have an impression of what products we have. So now let's go have a look at the technology behind it and where we come from. So Sky is running on a hosted private cloud, 2 data centers in Ireland. Why 2? For full DR, of course. We have an active and a passive. Some technologies there, typical technologies that we use are VMware, Cisco for networking, HP for the compute, Veritas for backup. But this layer is managed by our data center provider. Over the years, the load grew a lot. Sky was introduced in 2014, so that's almost 10 years back. And of course, we were successful and we grew a lot. So I want to give you an idea on the current load work we are handling with this system. So this is a graph showing you the number of incoming, we call that messages, per minute on our system. You see it follows the typical European business day, because Sky is mainly Europe. We have some Asian customers, like in Saudi Arabia and everything like that, but it's mainly Europe. So you really see a spike during European business day. We go up to 85K messages per minute, but one message always has multiple data points. So a message can be a position combined with a sensor reading, can be combined with a document coming from an onboard document scanner, things like that. So one message, one such an over-the-air message, will trigger multiple events downstream in our backend. As database technologies, we are currently using Microsoft SQL Server and MongoDB on-premise. So the backend, the database backend for Sky is Microsoft SQL Server and MongoDB on-premise. We started small there also, of course, in 2014, but over the years, we need to adapt to the load growth, right? So we introduced some new stuff on SQL Server, like we used in-memory tables. We switched to always-on clusters so we could read from secondaries. On MongoDB, we really switched from pure replica sets to sharded clusters. That whole transition went fully online. Also, yeah, we really start like the aggregation pipelines. We are using GridFS. So this is a bit of an idea on the current workload we are handling. So back to my story. Let's now imagine what the future of transport and logistics will be, according to us, how it will look like. So this is a very powerful slide. It shows you everything will have to be connected. There will a lot of electrification will be going on, and also autonomization. So we will have new devices delivering goods like drones or autonomous vans. In the passenger car, we foresee that the passenger car market, the people transportation market, we really see vehicle sharing coming up and even vehicle sharing autonomous vehicles. So you can imagine if you see Sky, we had to really think about our ambitions. We had to really adapt our services to be able and to be ready for the future and to be able to help our still help our customers in the future. So we started with the first thing is a new vision. So our first point in our new vision is really going global. As said, Sky is currently only in the EMEA region. We really want to go global, meaning transportation and logistics is also going global. Sorry. So we also need to go global. We really want to, within the transportation and logistics market, we really want to diversify our customer base, because now we are mainly at transportation companies. We really want to be also at the manufacturers, the guys creating the trail so they can, or trucks, so they can install our devices. We want to go to shippers, brokers of transportation orders, and also we want to start delivering really data as a product. The data we gather, for example, help deliver. We already have a customer where we give our position info to for traffic info. We want more connections. Going global will hopefully mean we have more connections. That will be giving us more data and better insights in the data. The more data you have, the smarter you can come on the data you're having. autonomous driving systems will require much closer follow-up. So where we currently have customers that are having positions for their trucks every 2 minutes, you can imagine with an autonomous vehicle that you have to be very faster, so every 2 seconds or every second or every 10 seconds. And we really want to evolve from a fleet management system to a fleet orchestration system. So we really want to be more proactive than what we currently are reactive. So if an issue occurs with a truck that cannot reach its destination in time, we give an alert to the dispatcher and we already immediately suggest a new route or a way to mitigate the problem. If you look at this vision, you immediately see there are quite some friction points with our legacy architecture of Sky. So we only have data centers in Europe. So going global with only data centers in Europe is not really a good idea. The current design was made from requirements of 2014. It was never meant to scale up to these kind of numbers. And it's very hard to start doing AI and ML on that architecture. So the conclusion was, we need a new architecture. We need to rethink everything, and we really need a new architecture. So out of that idea, out of that thing, SCALAR was born. SCALAR is our new product, so it's the next-gen solution we have, the next-gen, the predecessor of Sky. SCALAR is all about what needs to be transported, when does it need to be there, what it is, and do this in the best possible and efficient way. So this is the commercial name. We call it a Fleet Orchestration platform. So now let's have a look at the architecture behind it. So the architecture behind it, we really set off with the idea it needs to support a new way of working. On Sky, we had the waterfall, more the waterfall way of distributing software. So we had developer teams making software, then hosting teams putting it on our systems. So we really wanted to adapt that, and we really want to go to DevOps principles of work. We now have solution teams, product teams, and platform teams. Solution team is more high level, thinking about product close to the business. Product team is really developing. It's a team with multiple knowledge in it. There are developers in it, in such a team, product owners, things like that. And in a platform team is really the underlying infrastructure, helping the products teams to be successful and the solutions teams to be successful. We wanted to go fully CI/CD. We wanted to automate everything. We do that with community-driven templates, ERC templates, so infrastructure as code templates. Everything must be GitOps, so versioned in a repo, even our infrastructure as code. And of course, we wanted to be really focusing on user experience more than we did before. It became, from the start, obvious that if we want to go global, we had to go to the public cloud. We chose AWS, so SCALAR is running on AWS. And of course, the domain-driven design was very important, but also the switch from a monolithic architecture to a microservice architecture is very important. There, with microservice, we are allowing containers, lambdas. We are doing loosely coupling. We are using API first with BFFs, backend for frontends. And we are using all kinds of queuing and streaming systems in between to have the event-driven architecture also. So within this new architecture, we needed also a new database backend. So we really thought about what do we want from a modern database backend. And the first and foremost thing, most important stuff to us was it has to have a good ecosystem for developers. We saw on Sky a lot of friction between the developers and the database administrators and things like that. So we really wanted to go away from that. And we were convinced if we had a good ecosystem, developers would become more agile and be more performant and delivering features faster. So, of course, we went to the public cloud, so our database system needs to be built in the cloud, was to be compatible with the cloud. And, of course, public cloud agnostic, that's a nice to have, if it's not costing too much, of course. Also, very important, we want a flexible and adaptable database system, meaning we want to have a lot of data types supported, so we don't have to manage a lot of different database management systems, so a lot of types of database management systems. It must be, of course, as I said, we are really going into the GitOps way of work, so our database system had to be compatible with that. And also it has to adhere to the modern data management principles, so enabling modern data management principles, like it had to be very secure, resilient and high available. And of course, it had to have the necessary tooling to really do data lifecycle management. Having all of these requirements, we went to the market, and MongoDB Atlas seems for us the best choice. So why did we choose MongoDB Atlas? Because we know it. That's the first thing is we knew it. We ran MongoDB on-premise on Sky, so we had a lot of experience with the company MongoDB, with the support they deliver, and we were really impressed by the stability it had on Sky, running on-premise. The next very important point and advantage of MongoDB Atlas, it has a very, very, very good ecosystem. It's easy to onboard teams. It is fully integrated with CI/CD. It has, for example, MongoDB has its own supported Terraform provider, very interesting to us. It has very good developer tooling. You have Compass, you have CLI, you have a plugin for Visual Studio Code. And on top of all of that, the documentation is very good, and they have a really good learning experience. Third point is the feature richness. So, as I said, we wanted to support, we didn't want to support a lot of different database management systems, so it really ticked a lot of boxes related to our architecture. And this really meant we needed to support less database systems. And of course, MongoDB Atlas is really fast-paced in innovation. And then the fourth pillar, which is probably one of the most important ones, is the cost. On MongoDB Atlas, you have at a very low price, a multi-AZ, high available cluster, out of the box, and it's really, compared to anything else in the market, very cost effective. So now let's go to the next step, and let me show you how we integrate MongoDB Atlas and SCALAR. So on the management part, we decided we have one big MongoDB Atlas organization, and we will create a project per module and stage. So here you see the example of our Alarm Center. So Alarm Center is a module, and it has 3 stages, dev, staging, production. And this means it has 3 projects on MongoDB Atlas. The management is done by a platform team. Management meaning the users, the teams, and the API keys used by the product teams within their Terraform code. This really meant we didn't want no central DBA team anymore. We went away from that. And this also meant, of course, product teams are end-to-end responsible for their home module, also the data backend. On the deployment level, we are using, as I said, already infrastructure as code, and we started developing a Terraform template. So it's a general template, community-driven, internal community-driven, where the template will, for new starters or for teams not yet that familiar with Atlas, it will build for them a project, a cluster, the private endpoint into the AWS VPC, and it will create the necessary IAM roles or database users, depending on what they use. We really limited the way that they could deploy So we really wanted to, we are using GitLab as a CI/CD and a pipelining tool. And we only allow on dev, staging, and production to use GitLab with CI/CD pipeline. So it's not allowed to do any changes to your MongoDB Atlas environment on dev, staging, and production without doing it via Terraform. Of course, we still provide playgrounds to the teams, so every team has its own playground project where they do have full admin, where they can log in through the Atlas web UI, that they can make changes through the API, so they really can play around, getting to know MongoDB Atlas. Very important for teams new to MongoDB Atlas. So we have those playgrounds, and we have some teams using Liquibase, the open source version, for their schema management. Let's now have a quick look at an example data flow within SCALAR. So, the presentation is acting a bit strange, but okay. Apparently, it's not switching anymore. Sorry for that. I see it moving here, but it doesn't move there. Sorry. So perhaps I already can go to the next slide. The next slide was about which features are we using on Atlas. So we are using time series collections to store time series data, so sensor data coming from trucks and trailers. We are using online archiving, so we are using different ways of archiving, but for example, on MongoDB Atlas, the online archiving feature is very interesting. It's very simple to implement for teams. So we have the mantra to keep our OLTP database as small as possible. So if we can satisfy 90 to 95% of the reads with data that is online in the database, that's enough. So meaning we have databases only keeping 7 days of data and then archiving it. And we have databases keeping a whole year of data because, yeah, the typical user case is touching a whole year. So there we are using online archiving, but you're also using aggregation pipeline with the $out stage where you really can, for example, write data out of the database to a Parquet format. Very interesting. We are using TTL indexes for the data lifecycle management. So the default data lifecycle on SCALAR is 1 year. We don't keep data longer than 1 year in our online databases, on our OLTP databases. We are using snapshots to S3 for offline backups to other regions. And we are also using Atlas Search, which is very important to us because it really improves the user experience. And as, I don't know if you saw the presentation of Boris, it's indeed very, very nice that you don't have to do ETL and everything like that to a separate Elasticsearch cluster, for example, or something like that. It's really built in the database. It's tightly integrated. So the team is up and running with Atlas Search in a matter of minutes. Really crazy. It's really working very well. Then for aggregating data over time, for example, we are using triggers and functions. So this means we have functions running triggered every hour, for example, or every 15 minutes, aggregating data of the last hour, for example, and store it in a separate collection. So it's really optimized for reading. We are using charts to display some billing info about Atlas to the team, so they are really responsible for their costs also. Change streams is used to stream data out of the online the OLTP database down to systems for analytics. And the OBZ integration is also very important for us because every team can use this integration to get alerted on important database metrics. Let's now have a look at an example data flow within SCALAR. So this is an incoming data flow. It's a quite simple flow. Here you see the device, the hardware device. That's our own developed hardware device. It's talking to an IoT MQTT topic over the internet. We have a containerized application that is spreading that data out, putting it on multiple Kafka topics. The top flow, it will be hardened in our event logger database, we call that. That's really the raw data store. This data store is mainly used for support. So we really have still a tracing on which messages did arrive for which vehicle. We only keep 7 days of data in this database, for example. It's purely to be able to handle tickets on data problems. The flow beneath is really first enriching that message coming from the device with the asset info, because a device doesn't know in which truck or which trailer it's installed, so we need to link that together. And it's streamed further down to a real-time asset tracking database, where you really have, at any point in time, the current situation of your asset. Asset, for us, is anything you find interesting to track and to track. So it can be a trailer, truck, container, good, you name it. So here you see, for example, that we are using 2 MongoDB Atlas databases. We're also using still a DynamoDB. So this is really important to us. We never enforced teams to start using MongoDB Atlas. We never did that. We are still offering some other database systems they can use. So for relational database management system, we are not enforcing, but saying it's better to use PostgreSQL on Aurora. There, some teams really didn't want to step away from SQL, and they claimed it was needed for strong consistency and strong schema management. We also have the caching and key value use case, where we are caching, for example, results of database queries in slow-moving data, slow-changing data. It's interesting to just cache it, but data that's read a lot. And for queuing and streaming, we are using SQS, Kinesis, and Kafka. In the beginning, it was really like this. In the beginning, MongoDB was one of the options, which was really always weighed against PostgreSQL, a relational database system, or DynamoDB. But now we see, we are now almost 2 years building on SCALAR. Now we see it really has become the default database of choice for a lot of teams, because of the good ecosystem, of course. So now let's look a bit at our future. We really want to use MongoDB and MongoDB Atlas, of course, to help us reach our ambition. We have quite some, our management put some numbers on that, and one of the numbers is we want to grow to 1 million connected devices. We want to really keep innovating and with MongoDB and build new data products. And of course, when you go to the public cloud and when you start developing in the public cloud, cost is very important, because everything has to happen in a cost-effective way. So these are some improvements and optimizations we are constantly working on. So we want to scale up the team's core knowledge. Performance is a constant care. Security is constantly revisited, and least access privileges are done. On the cost part, we really are training the teams in designing to cost, like, for example, with auto-scaling up and down. Some other projects we're working on, we are looking at MongoDB serverless clusters for our dev and staging environments. We are looking on how we can best stream data from MongoDB to Databricks, which is our analytic backend. We will implement offline region backups. And these are a couple of the projects we are working on. So thank you for listening. I hope it was interesting, and have a good further afternoon.